Intuitively, we grow up to understand the gravity of Earth. It's present at every moment of our lives in many facets of our society and culture, our decisions and designs based on and accounting for it. But what is gravity like for things outside of our solar system? And how do we know about the gravity of things that are far away, and what are some of the extremes that we've observed? Hi, my name is Jocelyn Tchaikovsky. I'm an astrophysics major at Austin Community College, and today I want to talk about the Contemporary Physics Education Project's Gravitation poster, with a focus on binary black hole systems and black hole merger events. Gravitational waves were first directly detected on September 14, 2015, via the Hanford and Livingston Laser Interferometer Gravitational Wave Observatories, LIGOs for short. Gravitational waves were originally theorized in Einstein's general theory of relativity, where he had predicted that stars in binary orbits would generate these oscillating waves that would carry away energy from the star system. This consistent loss of energy would result in the two stars beginning to slowly spiral into one another before eventually colliding. The first direct detection of gravitational waves was not of a binary star system, however, but of two inspiraling black holes. Taken from the gravitation poster, this graph shows the amplitude of two separate readings of the first gravitational wave detections from the Hanford and Livingston LIGO observatories. The graph shows three distinct phases of the final seconds of the merger event between these two black holes: the inspiral, the merger, and the ringdown. The inspiral phase lasts for millions to possibly billions of years prior to the merger, beginning when the two black holes originally begin to orbit with each other. As the inspiral phase progresses, the two black holes will continue to irradiate the gravitational energy and begin to orbit closer and closer and closer to one another. And when these two black holes lose the energy required to continue their orbits, the merger event occurs. Shown between 0.35 seconds and 0.43 seconds on the plot, you'll notice that the gravitational wave readings strongly intensify during the merger phase. The peak gravitational wave power from the sample was calculated to be more than 10 times the power emitted by all the stars and galaxies in our observable universe. Despite being the weakest of the four fundamental forces, gravity is able to be pushed to this extreme due to the huge masses of objects involved. In this case, the two black holes weighed in at about 36 and 29 times the mass of our Sun. After the completion of the merger event, at around 0.44 seconds in the plot, the newly emerged black hole briefly enters the ringdown phase, and the gravitational wave readings will stabilize. Binary black hole mergers are still a fairly new discovery, and I'm excited to see what else we'll learn in the future. As an undergraduate physics major, I found the gravitation poster to be an excellent guide and introduction into the concepts and theories behind gravity, and I admire its ability to convey these complex topics in a digestible and still informative manner. Science education is a large passion of mine, and I'm glad to have been able to contribute to this contemporary physics education project. Thank you for watching this video.